All right, so our next section is 10.5, and it's called tangents. So we're going to learn about what a tangent line is, and there's a few other vocab words and theorems that we'll use. All right, let's get started. So first, the definition of a tangent line. It's a line, segment, or ray that intersects a circle in exactly one point. So it just grazes the circle. It only touches the circle at one point. So if you look at this picture here, it says RS and TS are tangent to circle P. So see how we have RS is here, TS is here. So it hits the circle at just one point. That point is called a point of tangency. So the point of tangency is the point where the tangent hits the circle. So if you want to label, this is a tangent. This is also a tangent. And then these are point of tangency. Okay, so those are some vocab words. Here's our first theorem involving tangents and points of tangency. So it says a line is tangent to a circle if and only if it is perpendicular to a radius at a point of tangency. So basically what that means is if you have a radius that intersects a tangent line at the point of tangency, like we have in this picture here, here's the radius, whoops, here's the radius, here's the tangent line. Notice the radius and the tangent intersect at, I think that was a P, yeah. At P, which is the point of tangency, that means that the radius is perpendicular. So you can mark that we have some right angles here. So that will happen every time you have a tangent line intersecting a radius at the point of tangency. So this is how we use this theorem. We have this picture here. It says AB is tangent to the circle at point B. Notice that BC is a radius. So since this radius intersects this tangent line at the point of tangency, that means we have a right angle here. And so what this creates, if you notice, there's a right triangle that's created, triangle ABC. And so that's what we're going to use to find X. Think about right triangles. We can use Pythagorean theorem. So we know that this part's 8. We know that this part's 9, and we have this is X. So we don't know what this piece is. However, this is a radius, and remember that all radii are congruent in a circle. So this is also 8, making this whole piece 17. So we're going to use that. That's your C, that's your hypotenuse, right? And then your 8 here is a leg, and then the X is another leg. So we would have X squared plus 8 squared equals 17 squared. So it's going to be X squared plus 64 plus equals 289. Equals 289. Subtract 64. So you have X squared equals 225. Take the square root and you get X is 15. So that's how a lot of times that right angle is used, Pythagorean theorem. Okay, another theorem has to do with if you have two tangents that intersect at the same point outside of a circle. So notice that we have AC here and AB, and they both intersect outside the circle at point A. What that means is these segments are congruent. So AC and AB are the same length. So AC is congruent to AB. That's a pretty easy theorem. So there's really not much to it. I mean, sometimes they're a little more complicated than this, but not much. So again, see how these two tangent lines, this was supposed to be a Q, it got cut off. So we have NP and QP are both tangents, and they intersect at P. So that just makes these equal. So X is just 12. Okay, so that's that theorem. And then we have one last definition. It's called a circumscribed polygon. So we've learned about an inscribed polygon. An inscribed polygon was in the last section, and that's when the shape is inside the circle. This is when the shape is outside the circle. So the sides of the circle are tangent to the circle. So what that means is that it just hits each side each side hits the circle at just one point. So there's a point of tangency on each side. So how we use this is something like this. For given triangle ABC is circumscribed about circle O, that just means that all the sides are tangent. Find the perimeter of ABC. So since we know that this is a circumscribed polygon, we know that all three sides of the triangle are tangent to the circle. So that means that all these rules that we learned, all these theorems that we just learned about tangents are true. So basically we learned that last one, when two tangents intersect outside the circle, they're congruent. So that would make DB congruent to BE. So if BE is 6, so is DB. AD and AF are congruent. So if AF is 12, so is AD. And then lastly, FC and EC are congruent. So if FC is 8, so is EC. So then it asks to find the perimeter. So we just have to add together the sides basically. So this side is 14. This side is 20. And this side is 18. So now for the perimeter, you just want to add 20 plus 14 plus 18, and all together it will give you 52 units. And so that's pretty much it for this section. It's a pretty easy one. So hopefully the practice is easy for you. But as always, just let me know if you have questions, and you can join our Zoom session at 11:30. All right, have a great day.